welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 permutations and combinations. We are moving on to miscellaneous exercise. Question number 1. How many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letters of the word daughter? So, total there are 8 letters in this word, and we can see that there are 3 vowels and 5 consonants. In this word daughter, we can see that 3 vowels are there and remaining are consonants. So, but we have to select only 2 vowels and 3 consonants. We can select 2 vowels and 3 consonants from the 3 vowels and 5 consonants. So, we can see that there are 8 letters. There are 8 letters in the word daughter, and 3 vowels are there and 5 consonants. 3 vowels and 5 consonants are there, and we have to select 2 vowels and 3 consonants. So, how many ways, number of ways of selection? Number of ways of selection is equal to, from 3 vowels we can select 2, and from 5 consonants we can select 3. And after selecting, we have to arrange them. We have to form many different words out of that 5 letters. So, we have selected 2 and 3, that is 2 vowels and 3 consonants we have selected. Now, we have to arrange, we have to make different words with or without meaning. So, how many different words we can make? So, total number of words is equal to 3C2 into 5C3 into, now we have already selected 5 letters. Out of this 5 letters, we have to make different words, and 5 letters are there and 5 spaces are there to arrange. So, we can arrange those 5 letters in 5 ways. Arrangement, we have to go for permutation. Selection, we can use combination, and that is equal to 3C2. 3C2 is 3, 5C3 is 5 into 4 by 1 into 2, and 5P5 means it is 5 factorial. So, simplifying that, we are getting 3600. That many number of words we can make. Next one, how many words with or without meaning can be formed using all the letters of the word equation? Equation at a time, so that the vowels and consonants occur together. So, here we can see that in equation there are 8 letters. There are 8 letters in the word equation. And we can see that here how many vowels are there? 1, 2, 3 and 4 vowels are there, and U, A, I, O, and remaining are consonants. And here it is told that these vowels and consonants, sorry, E also is a vowel. So, 5 vowels are there. Here 5 vowels and 3 consonants are there. And this 5 vowels, how many different ways we can arrange? And this vowel should be together, consonant should be together. So, 5 vowels can be arranged in 5 factorial ways, that is 5P5. So, here there are 5 vowels and 3 consonants. 5 vowels can be arranged in 5 factorial ways, whereas 3 consonants can be arranged in 3 factorial ways. So, therefore, total arrangement, total number of words is equal to 5 factorial into 3 factorial, then again one more 2 factorial is needed. Why it is so? Because the vowels together, consonants together. So here we can see the vowels if you are writing E, U, A, I, O, and remaining consonants are Q, T and N. So here this, first we have to take this as a single one, this as a single one. So two objects are there and we can arrange these two in 2p2 ways. Then only in between these vowels there is an arrangement that can be written in 5 factorial ways, and 3 consonants can be arranged in 3 factorial ways, and these vowels and consonants, they are separate, vowels together, consonants together. Those vowels and consonants can be arranged in 2 factorial ways, because this is 1, this is 1. You have to take this as single elements. Okay, this together taking as single, this also as single, we can arrange this 2 spaces are there and 2 elements are there to fill, that is 2p2 ways. That is, this vowels can be this side or consonants together can be this side. So there are 2 factorial arrangements for vowels and consonants, and in between vowels there is an arrangement 5 factorial ways, and in between consonants there will be 3 factorial different arrangement. So total arrangement is 5 factorial into 3 factorial into 2 factorial, that is equal to 1440 number of words can be made. Now third question, a committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of exactly 3 girls? So if it is exactly 3 girls, how many different arrangements are there? So total we need to take, we have to make a committee of 7. There should be exactly 3 girls, means remaining 4 should be from boys. So a number of ways of selection is equal to exactly 3 girls, means from 4 girls we have to select 3 girls. Then remaining, anyway total there should be a committee of 7. So remaining 4 we have to take it from boys. So 9, from 9 we have to take the remaining, that is into 9c4, and 9c4 into 4c3 is the same as 4 into 9c4 is 9 into 8 into 7 into 6 divided by 1 into 2 into 3 into 4, and simplifying that we are getting 504. Second sub question is at least 3 girls. That is, minimum 3 girls means maximum we are having only 4. So 3 girls, if you are selecting 3 girls, remaining 4 should be from boys. Or if I can select 4 girls also. If 4 girls we are selecting, remaining 3 from the boys. So number of ways of selection. Number of ways of selection is equal to that is we are having total 4 girls. So from 4 I can select 3 into total how many boys are there? Total 9 boys are there. So from 9 we can select the 4 remaining, that is total 7 it should be there. Then or I can select 4 girls also, because at least 3 means it can be 3 girls or 4 girls. So if I am taking 3 girls, remaining should be from boys. If I am taking 4 girls, remaining should be from boys, that is 3. Total we have to make a committee of 7. So this is equal to, so first one is 4c3 into 9c4, already we have got it as 504, and the second one 4c4 is 1, then 9c3, that will get it as 84. Total it is 588. Now third one, at most 3 girls, maximum 3 girls. So maximum 3 girls means 3 girls, then remaining 4 can be boys, or 2 girls, then 5 boys, then 1 girl, or then how many boys? It can be 6 boys, 0 girls, then all the selected can be boys. So these are the different possibilities. That is maximum, at most means maximum. Maximum of 3 girls. So how many different arrangement selection? So number of ways of selection is equal to 4C3 into 9C4 plus, that is or 4C2 into 9C5 or 4C1 into 9C6 or 4C0 into 9C7, which is equal to 36 plus 336 plus 756 plus 504. Simplifying, we will get adding up 1632. So understand what is the difference between at least and at most. At least means minimum of 3 girls. At most means maximum 3 girls. Minimum whatever it is. So maximum only 3 girls should be there. Okay. Now the fourth question. If the different permutations of all the letter of the word examination are listed as in a dictionary, how many words are there in the list before the first word starting with E? So if I am arranging this in the form dictionary words, so dictionary words start with A. So in this we can see that there are 11 letters. In the word examination, there are 11 letters, that is 2 A's. 2 A's are there, then which all repeats, 2 N's are there, 2 N's, then remaining I, 2 I's are there, then remaining all 1, and all others are different, and all other letters are different. And in the dictionary list, before E, only A out of these letters can come. If I am arranging in the form of the dictionary words, only A comes before E. That also we have to write in dictionary list. Before E, only A out of these letters, can come. So we can fix A as the first letter. So fix A as the first letter. So remaining 10 letters are there. 1A we have kept as the first letter, remaining 10 letters are there. So number of arrangements, number of ways of arrangement. Number of ways of arrangement is equal to, so first we are fixing A as the first letter. So 1A already fixed there. Remaining letters means out of 11, 1 is fixed as the first position, remaining 10 letters are there. It can be arranged in 10 factorial divided by, since the objects itself is repeating, we can take n factorial by p1 factorial, p2 factorial, etc. pk factorial. So here 1A already fixed as the first position, then remaining which all letters it is repeating, that we have to write it the denominator. So 2 n's, so divided by 2 factorial and 2 i's, there are also 2 factorial. 10 factorial by 2 factorial into 2 factorial, and we are getting it as 9,07,200. Okay. So now next one, how many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7, 9 which are divisible by 10 and no digit is repeated. So we have to make 6-digit numbers, and any number divisible by 10, then the unit place will be 0. So in all these cases, so how many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7, 9 which are divisible by 10. So we can understand that the unit place should be 0, then only it will be divisible by 10 and no digit is repeated. So 0 is fixed in the last position. So what we have to write? A number divisible by 10 have unit place digit 0. So digit 0 is fixed at the unit place and the remaining 5 places. So 6-digit numbers, 0 is fixed in the unit place and the remaining 5 places can be filled with the remaining 5 digits. In how many ways we can fill the remaining 5 places? In 5p5 ways. So therefore number of ways or required number of arrangement is equal to 5p5, because remaining 5 numbers can be arranged in 5p5 ways, whereas one space is arranged in only one way, that is the last letter is arranged as that 0 itself will come in the last position. So 5p5 into 1, that is equal to 120 different 6-digit numbers can be formed which are divisible by 10. Now next one, the English alphabet has 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So there we can see 5 vowels and 21 consonants are given. Out of that we have to make different words using 2 vowels and 2 consonants. So from 5 vowels we have to select 2, from 21 consonants we have to select 2, and it can be selected in 5c2 into 21c2 different ways, and after that we have to arrange those words, those letters should be arranged. So now we have selected 2 vowels and 2 consonants, so those 4 letters can be arranged in 4p4 different ways. So first we are selecting. So how many vowels and consonants we have to select? 2 vowels out of 5 vowels and 2 consonants out of 21 consonants have to be selected, and these 4 letters in 4 factorial ways, and these selected 4 letters, can be arranged in 4 factorial different ways. So required number of words is equal to 5c2 into 21c2 into 4 factorial, and which is equal to 50,400. That many words we can make. Now next one, in an examination a question paper consists of 12 questions. So in a question paper there are 12 questions divided into 2 parts, part 1 and part 2. Total there are 12 questions. containing 5 questions, 5 and 7 questions respectively. So from part A there are 5 questions and second one there are 7 questions. A student is required to attempt 8 questions in all. Total we have to attempt 8 questions, selecting at least 3 from each part. So if a person is selecting 3 from this side, total he has to attempt 8 questions. So here if he is selecting 3 from this side, 5 should be selected from the second part. If he is selecting 4 from this side, he should attempt 4 from the second part also. Then if he is attempting all the 5 from the first part, he can take 3 from the second part. So in how many ways he can select? Number of ways of selection is equal to 5C3 into 7C5 plus 5C4 into 7C4 plus 5C5 into 7C3. Then simplifying that, 5C3 is 5 into 4 by 1 into 2, then into 7C5 is 7 into 6 by 1 into 2, then plus 5C4 is 5, 7C4 is 7 into 6 into 5 by 1 into 2 into 3. 7C4 is the same as 7C3. Then 5C5, that is 1 into 7C3 is 7 into 6 into 5 by 1 into 2 into 3. Now simplifying this, we are getting, this is 10 into 21 plus 5 into, simplifying this, 35 plus 35. Total 420. Now question number 8. Determine the number of 5-card combination out of a deck of 52 cards if each selection of 5 cards has exactly 1 key. A deck of 52 cards. In this 52 cards, we are having 4 kings and 48 remaining cards. So in each combination, 5-card combination, there should be exactly 1 king. So number of ways of selection. Number of ways of selection is equal to, from 4 kings we can select 1 into from 48 the remaining 4 cards we can select, and it can be, that is 4C1 into 48C4. 4C1 is the same as 4. 48C4 is 48 into 47 into 46 into 45 divided by 1 into 2 into 3 into 4. Simplifying this, 7, 7, 8, 3, 2, 0. That many different ways of selection. Now question number 9. It is required to seat 5 men and 4 women in a row so that the women occupy even spaces. How many such arrangements are possible? So given that women occupy even spaces, given women occupy even places, that is, if women is kept here, that is W1, how many women? 4 women are there. So W1, W2, W3, W4. So men can be seated here, M1, M2, M3, M4, M5. So women can be, women is supposed to be in the even places, and then men can be arranged. So 5 men and 4 women can be arranged in this way. So number of ways of selection is equal to, so men, this 5 men are there, so 5 men can be arranged in 5P5 different ways, whereas 4 women can be arranged in 4P4 different ways. That is equal to 5 factorial into 4 factorial, that is 5 factorial into 4 factorial is 2880. Then next one, from a class of 25 students, 10 are to be chosen for an excursion party. There are total 25 students. Out of that, we have to select 10 for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. In how many ways the excursion party can be chosen? So, there are 3 students, either all of them will go. So, if all these 3 students are joining, what happens? So, 3 students are joining means, so we don't want to consider those 3 students' consent, because if one is going, all the 3 will go. That means I need only 22 from the 7, and from 22 I have to select 7 more, because 3 are already going. So, this is one case that if all the 3 are going. Suppose those 3 are not going. So, if they are not going also, then I cannot consider all the 25. They 3 are not going means then also I have to consider only 22, but from 22 I have to select 10. So, if those 3 are going, I have to select only 7 from the 22. If those 3 are not going, I have to select 10 from the 22. Because I can't consider at that time also 25, because if those 3 are not going means I cannot ask those 3. So, how many ways of selection? Number of ways of selection is equal to 22C7, that is from 22 I have to select 7, or 22C10. So, simplifying that, 22C7 means 22 into 21 into 20 into 19 into 18 into 16 into how many times? 7 times you have to 1, 2, 3, 4, 5, 6, 7 divided by 1 into 2 into 3 into 4 into 5 into 6 into 7. So, then same way 22C10 also we have to find. Simplifying, we will get the answer as, both we can simplify and write, we will get 817190. Then next one, in how many ways can the letters of the word assassination be arranged so that all the S are together? If all S are written together, how many ways of arrangements are there? Suppose all the S are together, so S, 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 4 S are there. Remaining letters means A, I, N, A, T, I, O, N. Now we can consider this all the S as a single unit. So how many different arrangements? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So take all the S's together. So therefore number of arrangements is equal to, here how many letters are there? Here up to this 9, and considering all the S's together as one unit, total 10 factorial divided by, now again each one repeats, A repeats 3 times. So 3 factorial, N repeats 2 times, then I repeats 2 times, and that is equal to 1,51,200. So we have to consider all the S as a single unit, and taking this as a single unit, here how many letters are there? Here 9 letters, count it and see, 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 1, this we have to consider as a single unit, so 10 divided by each one is repeating, that is A is repeating 3 times, so 3 factorial, N is repeating 2 factorial, then I is repeating 2 times. So here number of arrangements we are using n factorial by p1 factorial, p2 factorial, etc., pk factorial, because if the objects themselves are repeating, we have to use that theorem. Okay. So that's all from the miscellaneous exercise. Thank you. you.